Hello guys, welcome back to MathZone African Motives. Still on our engineering science and three, working on forces, and this is November 2023 exam that we're gonna check and see how we're given the questions from 3.1, where we are given to define the term equilibrium. All right, what is the equilibrium? All right, we know that the equilibrium simply is if you're talking about the equilibrium of two or more forces, it is that single force that will balance the forces under a certain consideration. So we can simply say, is this okay? Let's just see if this way is the single force. So is the single force. So this is just a single force that will balance the forces, meaning to say we're talking about two or more forces, all right, under a certain consideration. Okay, that is the idea that we have on an equilibrium. All right, we can have these guys in our own words, on explanation, which is fine. 3.2, consider the following forces that act on the same point. So all these forces that are here, they act at a certain point, and we had a question like this, if you still remember, when we were doing our revisions, we had something of this nature. So it's not first time. Okay, anyways, I'm just gonna explain here what we're supposed to do. These compass, this is the way that you're supposed to present on a compass, all right, taking into consideration your compass bearing. All right, so let us just have an indication of our compass in this case. So we're gonna have our compass, which has got the north line and the south together with the west and east. All right, so this is gonna be the north, south, this is our west, and this is the east. So what you do, in fact, I'm gonna show you another way or method of taking our components. All right, I explained components that are taken at a certain point. Today, on this class, I'm gonna show you guys how to take moments, and to take your forces in another way. Okay, I just hope you're gonna understand me. Okay, let's indicate these ones first. The first one is 25 kilonewton west. So this is direct in the west. All right, this is our west here, direct in the west. There is a 25 there. 25 kilonewton in the west. Then there is 35 kilonewton in the east, direct in the east. There's a 35 there. In the east, there is a 35 kilonewton. Then directly to the north, there's a 100 in the north. Here, there's a 100 kilonewton. Then directly south, there is a 60 kilonewton to the south. There's a 60 kilonewton to the south, and the last one is 20 kilonewton northeast. They even gave us even the angle, guys. This one was just direct, all right, because you're supposed to know that if it is northeast, between north and the east, it is taken at what? At a 45 degrees, all right, as long as the northeast is taken at what? At 45 degrees. And that is what? 20 kilonewton there, 20 kilonewton. All right, so that was the information. Okay, that's it. So the question here was, from this information, as we've got the diagram, calculate 3.2 the sum of the vertical and the horizontal forces and state the directions. All right, so that's where I said I'm going to explain another way or another method here. It's the same thing, but just the way that you take it. All right, remember I said 3.21, the sum of the vertical. Let's start with the vertical components. All right, also from your formula sheet, I'm just going to also show you how you are given this so that you can also follow your formula sheet. All right, this is for the vertical. The vertical is for the y-axis. All right, so the vertical is for the y-axis, so we use Fy, which takes F sine of theta. But if it is the sum, we're going to take this F1 sine, this F, and so on and so on, all right? So you're going to add your forces, all right? So using this formula, I want you to understand this. You're going to take your forces from the origin. All right, this is the right. Okay, let me explain this way. Maybe you understand me, guys. You will take your forces, I mean your angles from the origin, all right? As we know that going this way, that is our angles are positive, all right? So this will be at 0 degrees. This is the initial point. Let me take this one. This is at 0 degrees. This is at 45 degrees, all right? This is at 90 degrees. This is at 180 degrees. This is at 270 degrees back to 360. All right. So if you take these forces as they, I mean, these angles as they are, you are going to add everything. There is no subtraction. There's no what. You just take as it is. So it's going to be like this. The sum of the vertical, we saw that the vertical is y, therefore the y-axis, and it uses sine. So this will be 35 sine of 0. So you're going to have 35 the sine of 0 degrees plus 20 sine of 45. So you're going to have 20 the sine of 45 degrees plus everything you're adding with this method. Angle of 90 degrees there. So it's 100 the sine of 90 degrees. All right, we move on to this one. That's a 25. Whether it's on this side, it's no, there's no subtraction. Just take as it is. 25 the sine of 180 degrees plus, we move on to this one. That's 60 sine of 270. So it's 60 the sine of 270 degrees. All right. So taking this, you add everything. You add everything. All right. That is taken all the angles from the positive horizontal axis in the anti-clockwise as they are. You add, there's no subtract, there's no what. The calculator and the angles, they will simplify as you are having on your calculator. That is going to be 54,142 kilonewton. All right. But if you are to consider that previous case, remember we're saying our angles should be taken back to the what? To the horizontal axis. Like if we are taking this angle, it must be 45. This must be 90. This angle, you can take it this way or you can take it this way, but the angle there between is 90 degrees, all right? Then this one, meaning to say it cannot be a vertical, all right? This cannot be a vertical as we know. It's a horizontal, it's a straight horizontal, this one. Also, this is a straight horizontal. So in our actual sense, we're supposed to just say this is on the left side. So it is going to be 20 sine of what? Of 45 degrees, all right? It's above, which is a positive, all right? Also, 100, it's a straight vertical. This is a straight, it's direct in the vertical. So it's just gonna be plus 100. And we've got a direct vertical going down, which is a minus 60. This is what we're used to. But if you are using the angles as they are direct from the origin, from the positive horizontal axis in the anti-clockwise, you shall add everything together. Still, you're going to get the same answer, all right? So like I said, guys, as we are moving, we're going to have new ways and so forth. And we know that vertical to be positive is either vertical, you're going up or down. So up it's north, down is south. So being positive is what? It's north. So this is affected to the what? To the north. Okay. Then we go on to the horizontal. All right. We saw that on that part on the horizontal, this is the one that uses fx. Okay. If you check here, the one on the horizontal from our formula sheet. All right. Here, f of the sum of fx, the one that uses what? The cosine of x is your horizontal. So that is going to be given as, sorry, I just want to go back this side. Okay, so here we're gonna take the horizontal, like I said, it's gonna be fx. So the sum of fx is gonna be, we take everything. So this one, the advantage of this is that you are just gonna change everywhere where there is a what? Where there is a cos, well, a sign, you're just gonna put a cos. So this will be 35, the cos of what? The cos of 0 plus 20, the cos of 45 degrees plus 100, the cos of 90 degrees, plus here 25, the cos of 180 degrees, plus 60, the cos of 270 degrees. That's the advantage of taking your forces from what? from the positive horizontal, I mean your angles from the positive horizontal in an anti-clockwise direction, you add everything as it is. And what you had here is the same as what you're going to have here, which is different from that other way. The other way of analyzing our diagram is that we check, okay, the horizontal, this is a straight horizontal, as you can see, and it's on the positive. So it's going to be 35. All right. This can be written on the positive side of the horizontal. So it's going to be 20 cos of 45 degrees. There's no way that this can be a horizontal. It's a straight vertical. It can't be a horizontal. It's impossible. All right. Then we've got a vertical on this side, which is, I mean, a horizontal on this side, which is a negative. So that's negative 25. It's a straight horizontal. Also, this cannot be a horizontal, no matter how you try it. It's a straight vertical. So there's no way. So meaning to say, you're just going to simplify this. All right. You get the same answer as this part that I am explaining on this side here. You are simply going to have the same answer, and that was going to give us the horizontal component in this case of 24. The sum there was going to be 24, 142,135, and so on. So it's going to be 142 kilonewton. All right. So also the direction, we have to take a closer look. Which direction is it? The horizontal is either you're going to the east or you're going to the south. The east is positive, I mean, or to the west. West is negative. So as it's a positive, so it means we are going to the east. All right. So this whole part is of the east. All right. That's being a positive. It's connected to the east. Okay. Now that we have this, let's check the other part of the question. Here they wanted us just this, all right? Then after that, the magnitude and direction of the resultant, right? 4 marks for that. So you need the magnitude and the direction of what? Of the resultant. So this is what you do. You take these forces that you got the vertical and the horizontal that you got in this case, all right? So this is 3.22. All right, this is within the north and the east. The first one is on the north, the other one is on the east. So what we're going to do is that we have to look for a quadrant, or we have to find one of the quadrants that carries the north and the east at the same time. All right, which quadrant is it? Okay, so it's like this. Okay, just something of this nature, guys. This is our north. So I'm just going to focus with the north only and the east. This is where we have the east. So this is the quadrant which carries what? Which carries north and east at the same time. So that's where you draw your triangle. Remember, from your trigonometry, the triangle that you draw in the first quadrant is like this. You do the same thing. This is now trigonometry, guys. This is no longer about forces. You're back to trigonometry there. All right. So as you can see, this is the horizontal component in the x-axis. Remember, that's our x-axis and that's our y-axis. So the fx is for the horizontal fx. So you're going to write this in the horizontal 24,142 kilonewton, and fy for the y-axis. This represents what? The y-axis, which is the vertical. That's 54,142 kilonewton. So this is going to be our resultant, and this is going to be our direction theta, or you can use this one as your alpha. All right. So I'm just going to use this one inside of the triangle. So like I said, this is no longer about science, guys. This is now you and your mathematical skills. All right. You are back to trigonometry there. How do we calculate the resultant here from our trigonometry? This is what? The Pythagoras theorem. So from Pythagoras theorem, we understand that r is equal to the square root of the shorter side squared and other side squared, which is the square root of fx squared plus fy squared. Also, let's check here from our formula sheet. I think we have got this formula here. So they give us here the r is equal to the sum of fx plus the sum of what? The sum of fy squared. So the formula there is given, all right? That is the sum here, and also the sum of what? Of fy, the one that we got. So it's simply there. We have got these guys on our formula sheet. So it's not a problem. So that is our fx. That's 24,142 squared plus the sum of the Fy, we got 54,142 squared. So that was going to give us the resultant, which is 59,281. So this is the magnitude of the resultant. It was supposed to be 59,2806 and so on. So to 3 decimal places is going to be 281 kilonewton. All right. And also the direction, which is our theta in this case, between the east going to the what? To the north. So that's our theta, which is the direction, which is equivalent to the arctan of the opposite, which is our Fy, in this case, the sum of Fy and the sum of what? Fx. So it's simply the opposite, which is the sum of Fy over the adjacent, which is the sum of what? Of Fx. We also have this formula. I think we're given this one. Let's check here. All right, tan of this, or you can just take a tan theta, it's Fy over this. Then if you want theta, it's going to be arctan of that, all right? So you can just take it that way. Okay, you can just take it that way, which is a direct and straightforward formula. So meaning to say, now if you want theta, it will be arctan of that. So theta is simply going to be arctan of the opposite, which is our opposite, that's Fy, which is 54,142. Like I said, we are back to our mathematics over the adjacent. Remember, opposite of adjacent from tan, which is 24,142, like this. So that's our theta is equal to arctan of this is going to be 65,96783, something like that, to 3 decimal places. That will be our theta is going to be 65,968. This is going to change to 8, or you can just fix your calculator to 3 decimal places. Then your answer is automatically to 3 decimal places. All right. So therefore, our resultant in this case was going to be 59,281 kilonewton at, like I said, the direction is between the poles that we are given, the east and the north. We are moving from the east going to the what? To the north. If you move from the north, it's going to be north to the east. We use this angle, which you take as alpha. But in this case, I'm going to use the theta that we calculated. So it's east going to the north. So that's east, the angle that we calculated here. So this will be at east, the angle of what? Of 65,968 degrees to the what? To the north. This is our direction now. Okay? So this is the information. That's the information that you're given. So you have to be very, very careful how you attempt your questions. Very, very careful how you attempt your questions. All right. So like I said, that's the information that you're given. And we just have to be careful how you attempt our questions. Okay. So it was like that. Okay. It was just like that. And let's check the other part now. They want us to calculate the magnitude of the equilibrium. Remember, when it comes to the equilibrium, it has the same properties as the magnitude of what? The resultant. The resultant, our magnitude was 59, that is this value that we have. So it is going to be the same thing as for the what? As for the equilibrium in this case, all right? So 3.23. So in this case, for the equilibrium, our magnitude in that case is just going to be what? 59,281 kilonewton. They have the same magnitude, all right? That is the idea of the question. So that was our question, guys, on forces, which is 12 marks, everything in this case. Just to understand this question, you can see that, all right? Guys, this is too much. Let me see. All right, like this. So know your steps, all right? How to operate your diagrams and the angles and so forth. As you can see, I think as it comes to forces, this was one of the questions which was a little bit direct. Okay, I don't know what's your thoughts on this one. All right, I think it was just a fair question. All right, so just a fair question. We shall try to have more questions on forces again so that we'll be able to revise typical questions like this one that we just had. So maybe you might have another question like that in the next coming exam.